So, welcome everybody. We're in the Education Forum at Spark and AI Summit 2020. My name is Rob Reed. I'll be your moderator. Thank you for joining us, and a few tips before we get started. If you have a moment, let us know where you are joining from in the discussion comments. So if you look down sort of in that direction, there should be a text box where you can type in who you are and where you're from. Let's see. Please put questions in the Q&A box on the right side of your screen. So that's going to kind of be over there. Hopefully my finger is pointing in the proper stage direction here. And we will do our best to answer those questions as they come across. And we will also have a 15-minute section at the end for Q&A specifically. During the session, please be respectful of others and follow the virtual code of conduct. So if you wonder what is the virtual code of conduct, there is already a question there. Where can I find it? It's online. So we will be making sure that the discourse is respectful. If you have technical issues, your best bet is to, one, make sure you're not connected via VPN. Two, to make sure that your settings on your local computer are properly configured for your browser. And there's a Summit Help Desk link on the lower left-hand side of your screen. And you can click that and chat live with Meeting Play technical folks. So with that, I'm going to turn it over to Mr. Mike Maxwell. And Mr. Mike Maxwell has over 15 years of experience working with government, education, and healthcare on big data, analytics, and cybersecurity solutions. Mike currently leads the U.S. State and Education organization at Databricks. Prior to Databricks, Mike led national education, state, and local organizations at both Tableau and Symantec. And in addition to the private sector work, Mike has also worked in the public sector at the U.S. Veterans Administration and the United States Senate. With a passion for family, skiing, and mountain biking, Mike lives in Salt Lake City, as you might expect, with his wife, who is a University of Utah professor, and he has a teenage son and a daughter. So, Mike, if you want to go ahead and take over, we'll go from there.
Okay, great. Well, thanks, Rob. Good afternoon or morning, depending on where you're at, everybody, on our forum today. Really excited to have you here. Really excited to have Rob and our illustrious panel of speakers. We will introduce them more specifically a little bit later in the program, but we've got a great group of folks with a really impressive background that we'll be talking to and talking with today. I'm excited to be here. This is we're in a really transformative time in education, and probably not even as much as we even fully appreciate right now. And at Databricks, when we look at big data and analytics and AI, we see this really sort of mushrooming role for those capabilities to be applied in education in a variety of different areas. And we'll talk about some of those areas throughout this session. We really believe that Databricks is very uniquely positioned and capable in this arena to really help support some of that transformation and that innovation that's happening. Now, with Databricks, if you're not too familiar yet with Databricks, sorry, I'm flipping my slides too quickly here.
Mike, your presentation's not coming through on my screen. So I don't know, Charlie, Colby, Donghua, can you see his slides? Charlie, yes. Colby, no.
I can.
Mike, I'm going to let me take over as speaker and see if I can share, see if I can share my screen.
Okay.
You can still talk.
I will keep talking then, and you can figure out the screen. I can see the screen on my end for what it's worth.
Yeah, Rob, I think it might just be yours. You might just want to refresh and come back into the room.
All right, great. Then go ahead and I'll jump off the speaker then.
Okay. Can everyone still see my screen?
Yes.
Okay, cool. All right. So, if you're not already familiar with Databricks, just very high level, we like to refer to ourselves as a unified data analytics platform. And really what that means is we help organizations wrangle together a really complex array of data so that analysts and data scientists and knowledge workers and leaders in those organizations can use that data to really create actionable intelligence to exercise their public service mission. And so through this session, you'll hear some discussion about many of the current use cases that Databricks is being applied to, but I think some really forward-thinking thoughts on what that can look like in the future as well. So I'm going to spend a couple of minutes teeing some of that up first here. If we look at the, in education, and this is true, I think, across industries, there's been this journey of analytics that we've seen, and that's really defined what a unified data analytics platform looks like, and that has evolved over time. It wasn't that long ago when a data warehouse was considered a unified data analytics platform. And these data warehouses were a really good start as long as they were dealing with really structured data, things like student registration information, grades, some static reports that organizations were running. With the Internet of Things developing and just the expansion of different kinds of data in the Internet, the diversity created that didn't fit data warehouses as well. So you've got things now like data that's the result of streaming webcam video. You've got social media feeds that students and educators and others involved with education are engaged with. There are real-time interactions happening on Canvas and Blackboard and online learning systems that have insights that can be drawn from them. We have everybody's favorite Zoom sessions now. Again, a lot of digital content there, both video, but also just interactive that can serve an understanding of the learning process in education. And with all of that, data warehouses, is at least the old model, have really become quite inadequate as serving the mission of education. Even if you can get all that unstructured data together into your data warehouse, all of those things I just mentioned, by the time you got it there, you might have missed the window to take some actionable intelligence on that, with the goal of getting to predictive analytics. And that's a big promise of big data. Predicting student success and understanding the causal factors that lead to student success. Now we're about predicting pandemic factors and their impact on student enrollments and participation. Predictions of alumni giving, big concern with a lot of transformation going on in higher education. All important, trying to predict fall football attendance. That's can be a big data challenge. And so some of the institutions we've worked with have evolved to adopt some predictive capabilities from their big data. They're on that journey, but most, in my experience, are not there yet. Where we really want to go that's even beyond prediction is artificial intelligence, AI, and particularly AI real-time, and the ability for AI real-time to allow our machines to make us smarter in ways that can allow us to do things faster and more effectively than we could do by ourselves. Things like how does what data can inform a teacher in an institution to optimize their real-time engagements with students in an online learning platform, maybe in a Canvas session or with a classroom in a Canvas session. Zoom session, kind of the same story. Lots of digital information coming. How do we use that to optimize the learning experience in the classroom? If we think about student recruitment, there's a variety of social media and other sources that continuously feed and can serve the mission of attracting the best and the the students that are the best fit for the programs we're looking to promote. If we think about advancement and fundraising, interacting with alumni and other funding sources, how do we engage with them in a way and pivot on the fly to the kinds of messaging and the kinds of issues that they really care about that will draw their attention and have them be inclined to support the institution financially. So all of those things are examples of where that journey from warehouse to predictive to getting to autonomous decisions through AI can be really impactful in education. Now at Databricks, my role is to lead the national education and state and local government organizations. And it's really fun and exciting for me. I get to travel. I used to get to travel. Now I get to talk to people all over the U.S. about what they're doing with AI and predictive models and big data and analytics, and how do we optimize that. And you're going to see some of that content, some of that sharing happening in our conference this week. If you were able to be on the Rush University session earlier this week to see some of the work that they're doing in their teaching and health programs. I know Medical University of South Carolina presented, their chief data officer presented in the VIP session on Monday. If those of you that are fortunate enough to be in that session got to get some information on that. Friday morning this week, Indiana University will be presenting along with one of our really impactful business partners, Kenzai, in a session with a host of capabilities that IU is applying across the university and in their medical centers with Databricks. I am excited. Tomorrow I get to host a fireside chat with Matt Turner, who you see on your screen. He's the Chief Data Officer at the Medical University of South Carolina. And I'm also very just pleased, and I want to congratulate the MUSC team on being a finalist in our annual Databricks Data Team for Good Award. This organization has been doing some really amazing things with Databricks, particularly to inform and respond to the COVID pandemic crisis in South Carolina. And if you want to hear more about that, the work they've been doing, our session tomorrow afternoon will be addressing that. So we've got some really good content, but we have certainly many other educational institutions that are leveraging Databricks to do really powerful things. Now, to frame how Databricks, kind of as in our business, if you will, looks at education, we really bucket it into three areas. There's an administration area, a classroom area, and a research area. And I'll touch on each of those because I think the speakers and the panelists I expect will touch on all of these areas. First area is administration, and this is really how an educational institution runs the institution, how they run their operations. This is things like fundraising and alumni giving and grants and tuition and other sources of revenue, as well as just the operation, even the physical plant operation of the university. It also includes, importantly, that process to recruit students and faculty, and how big data can play prominently into how students and faculty are brought to the institution. In the classroom is probably the most important area, kind of have it in the middle of our chart here. And this is all about what happens in that learning experience in the classroom. Big data will play a critical role in that evolution. I'll talk a little bit more about that on the next slide. Big data analytics is also taught in the classroom. The next generation of data scientists and data engineers and other knowledge workers working with big data is part of our educational experience. And so I've been really excited about just earlier this month, we announced our Databricks University Alliance program. We'll talk a little bit more about that later as well, but Rob Reed, who's moderating this session, has just done a fantastic job rolling that program out for this year and bringing so many great benefits. Many of them are being free to both students and teachers as they're teaching big data and analytics in the classroom. Third area is the research area. And in this area, we see Databricks being utilized for all kinds of just really impressive things. Genomics research, all kinds of COVID-19 related activities. Saw a program last week of some global supply chain modeling research that was being done with Databricks, political science studies, weather forecasting. One of my favorites, so we've got a customer that's leveraging Databricks for astronomical analysis, searching for FRBs and exoplanets, and using the enormous amount of data they're drawing off of telescopes to do that. So, just an impressive array of really powerful things that researchers are doing. Moving with Databricks being a solution that lives in the cloud, it's also made the process of getting the tools to do this research much easier. In the past, quite often, if you were going to use computing resources for your research, you would have to go through a grant process that would require you to request to buy IT hardware and software, and then you'd have to bring it in-house, and then you'd have to have spend time having and expense with IT setting it up and running it and maintaining it on an ongoing basis. And what the cloud and Databricks' ability to live in the cloud exclusively really brings some agility to bringing these kinds of assets up and available for research purposes, and being very nimble about how we do that. Again, I expect you'll hear from our panelists today on all three of these topics, and probably more than that as well. I want to dig a little bit deeper into the topics of online learning, which is an important area when it comes to data and analytics. Rob mentioned that my wife's a university professor. I've got a 17-year-old son who just finished his junior year of high school. I've got a daughter who's working on a bachelor's degree. I have a son-in-law that's in a master's program in mechanical engineering. Well, all these people that I care a great deal about have had to pivot to online learning almost exclusively in the past few months. And I'll candidly say it's not going very well. My 17-year-old son in particular just hates the online learning environment, despite the fact that he will spend endless hours online gaming and socializing online. But the learning experience is nowhere near as compelling through that digital medium as some of those others. And so whether it's my son or others in my family, they've all had challenges with this evolution. We still live in a learning model that was built around a brick and mortar experience for classrooms. But much in the same way that retail and many other industries have had to evolve from brick and mortar to online, education really now out of necessity, accelerated by the COVID crisis, is having to make that transition. In this digital world, interaction between students and teachers are in some ways very different than in a brick and mortar classroom. In the retail world, data and analytics really informs buyers and sellers about the experience, the sentiment, satisfaction with that interaction. And those same kind of analytics can be applied to the online learning world in really powerful, impactful ways. Globally, that's not a pervasive practice yet. This is a very new thing. But there are some exceptions where we are seeing some institutions doing this and doing this very well. Unfortunately, there are a lot more examples of students, in some cases, demanding their tuition be refunded. In other cases, there are now class action lawsuits against universities just because of the dissatisfaction associated with that online experience. And so the opportunity with big data is very rich in terms of the ability to inform your universities, our educators, as to how that student experience is going, even in a real-time basis, to optimize and improve it. Rob Reed and I actually just authored a blog on this topic, and we referenced to that blog, and you see it on the screen here, but and you can see it at Databricks, Databricks.com. A couple of great examples, one from UC Berkeley and one from Western Governors Universities, on how those institutions are really applying analytics to understand this student-teacher interaction and what the student's experience is, and really optimizing on that. So if it's a topic you're interested in, please read our blog, and if you don't read our blog, I suspect there'll be some really great thoughts shared on this session today with our panelists. I think this is my last slide. Actually, no, I have one more slide after this. So this slide's kind of busy, and some of you that are familiar with Databricks have probably seen this before. We call it our layer cake description of Databricks. And I'm going to give just a real high overview of this in terms of what this looks like in the higher education world, where Databricks, we live in the Amazon or Microsoft Azure cloud. And so that's the bottom layer of the cake. The middle layer of the cake is we'll call this the data lake, or what is now more and more becoming called the data lake house, where all of the benefits of both the traditional data lake and a data warehouse are being combined into this great data wrangling layer, so that all kinds of data, structured data and streaming data and anything that is digitized can be brought together in one place, and that then be curated in such a way that it can be really useful to the top layer, which is where all of the analysis and visualization and AI type functions are built by people that are data scientists or machine learning engineers or business analysts that are capable with those tools. So that rich variety of data, we can bring it into this environment. It can be served in really impactful, practical ways to address the results that are so important in higher education. Student success being at the center of that, but we also want to address things like enrollments. We also need to address fundraising to have our institutions be viable. And so a great set of capabilities and issues can be addressed with Databricks, and with our modern approach to doing this, and by leveraging the cloud, these kinds of environments can be stood up in hours or days, as opposed to weeks or months or years with some of the legacy technologies that we talked about. So in Databricks, the company, we started as an education project at the University of California, Berkeley. We're really committed to this this segment as a part of how we bring our solutions to the market and to the industry. And that's segue to my last slide, which is I do want to again highlight our just recently announced Databricks University Alliance program. This is free software and content and courses for students. It's also an online community, as well as free teaching resources and software for teachers and instructors to use. I feel like this is just a really exciting resource for anybody that's involved with education to be able to leverage and really serve that mission of preparing that next generation of knowledge workers for the kinds of unified data analytics platforms that Databricks is able to serve the market with. And since Rob Reed is the guru of this program, this is, I think, a good segue for me to pass the ball to Rob and have him take us into the next section of our session here. So, Rob, if you're good to go, the platform is yours.
Thank you so much, Mike. Just doing a little triage on the back end. Let's see, updates to the audience. We are having an occasional issue with sound, so if it comes in and out, then that could be a platform issue. So do your best to hang in there with that. And I've also gotten some feedback from Kristen that maybe some of the questions on the Q&A are not coming in. So just be patient. If in about 5 minutes we don't have the Q&A updating, then we can just ask you to shift your questions to the comments window. So just bear with us on the technical things, and we'll get through it. On the University Alliance, thanks for the queue up on that, Mike. Just email us at university@databricks.com if you have any questions, if you're teaching or want to teach, or your institution is interested. It's me on the other end of that email, and that's what I'm here for. So let me shift now, and I'm going to turn my camera off because y'all don't need to look at me anymore. And just introduce the panelists that we have. We've got Colby Ford, Dr. Colby Ford, who is an associate faculty member of the School of Data Science at the University of North Carolina at Charlotte, and he is also a bioinformatics researcher in the Department of Bioinformatics and Genomics. We've got Donghua Kim, who is a vice president at New Wave Technologies and an adjunct professor at the University of Maryland, Baltimore County, where he teaches data science courses to graduate students. And then finally, Charlie Linville, who is a visiting associate professor of statistics at the University of Illinois Urbana-Champaign, where he teaches data science foundations. So Charlie, if you would like to take over as speaker, the floor is yours, and I'll go back on mute.
Yeah, so good morning, good afternoon, and good evening for everybody, wherever you may are. So my name is Donghua Kim. I am an adjunct professor at UMBC, University of Maryland at Baltimore County, and I also work as Vice President of Engineering at New Wave. That's my day job. So I just want to take a moment and then give introduction about UMBC and where we are located at and why we think data science is really important for the students that to whom we are delivering the education to. So UMBC is a dynamic public research university, and we really pride ourselves in terms of the culture that is inclusive. So before we get into more detail about that, I just wanted to show you our mascot, which is Chesapeake Bay Retrievers. So just bragging about our school. So we were ranked number 9 as the most innovative university and number 12 top university for undergraduate teaching in the nation. And THE, rated as the number 3 in the U.S. and number 62 worldwide, and other recognitions, as you can see. As I mentioned, we're very inclusive. We are a very diverse university. About half of our students, more than half, are non-whites, and we have a huge population of Asians and Africans. So we really pride ourselves in terms of being inclusive and diverse university. Yeah, can you hear me?
Yeah, I can. Can you reshare your screen? I don't think it's showing.
Okay, let me try again.
Yeah. Sorry.
No worries. There
Okay.
we go.
Looks like I'm not the only one either.
Is that coming out?
Yeah, there we go. Okay. Continue.
Okay, all right.
Thank you.
All right. So, like I mentioned, we're a very diverse university. We're very inclusive. And data science, we have a very robust data science program. At our grad school, we have about 200 students enrolled in the program. And we teach from statistics to 601, which is introduction, all the way to big data management. And 603 is a course that I'm going to be teaching, which will be introducing Apache Spark. And this is in conjunction with Databricks Alliance program that Rob has spoken about. So, we are really grateful that Databricks, along with Microsoft, they are able to provide a grant for the university so that we can have that cloud environment in which we can run, data analytics using Apache Spark within the Databricks environment. So why is data science important to students who are coming from UMBC? So as you can see at the top, right top, is where the school is located at. We're just outside of Baltimore. We're in between Baltimore City and Washington, D.C. And as you can see, there are a lot of government agencies within this area, including Centers for Medicare and Medicaid Services. We have Social Security. We have NSA, National Security Agency. Homeland Security, and DoD. So all of these agencies, they are very big into data analytics and predictive modeling, coming up with machine learning and AI. So being situated in this environment, along with other big hospitals such as Johns Hopkins. So data analytics and being able to have the kind of tool sets in terms of machine learning AI is really crucial in terms of finding the right job and being able to sort of make that impact within the community. So I just want to hand this over to Charlie. Are you ready?
We'll give it a go. So one of the things that intrigues me about cloud computing is that it can be both a subject of instruction and an enabler of instruction. But it can take a little bit of time to bring others onto the team of folks who are looking to help make that happen at an institution. And so the slides and remarks I've prepared are, to some extent, one way to describe the thinking that we might go through in order to decide to bring something like Databricks into use in instruction at an institution like ours. And so I wanted to thank a number of folks who I've had the privilege to work with at the University of Illinois. If this were a conventional presentation rather than a panel, these folks would be my co-authors, and I very much appreciate the chance to work with them. So I'd like to pose some questions for us to think about. So when do we think students would be most likely to need compute resources? So, from time of day, day of week, which months in the semester. I'm guessing we all have a pretty good sense that they need them more in the late evening and in the morning. On Tuesdays, immediately before an assignment is due, if it's due on Wednesday. And in a fall semester, if projects are due at the end of the semester, probably much more computing is happening then. And so I think this informs some of the technology choices that we make. And I found a lovely and compelling visualization of how students spend their time. I invite you to take a look at this elsewhere. I took some of the same data and then imagined it in a slightly different way. And it ends up that as we look across the hours of a day, going from just after midnight to 2,300 hours, we see that students are likely to be spending their time in different ways at different times of day. And I think that can form a nice part of a cloud computing story as well. More questions that I'd like you to consider. So when do we know how many students will be in a course? And when do we know what students will select for projects? And do we really know at the outset how much compute resources we're going to need, especially if we're teaching in an area where things are changing a lot, and that change is very important to us, and we want to keep up with those changes. And so with those as first thoughts, I'd say, why should we pay for compute resources when they're not going to be used? And can we find ways to make sure that we have enough compute resources at the times when we need them to allow truly authentic experiences with data and encounters with the magnitude of the data and the consequences it has? And I think that in addition to those nice opportunities of adapting to when there is need, I think we can also think of instruction in computing, instruction in data science and cloud computing as being a time where people are needing to figure out how to safely work with something that's new to them. And there are other places where this happens as well, training of new hires in R&D entities, in startups, etc. And so as I think about that, I think of other times when we need to sort out how to safely and productively operate a technology that's new to us. New drivers. And so here we see a little picture from my my own Subaru, and then a picture from a rental car that I had a chance to drive recently, and I noticed that there are lots of nice safety features on this new rental car. So we can see things like Databricks deployed in the cloud as a way to give our students experiences with things that are more similar to what they will see in the future in their careers than legacy systems that may already be present. And so this way, this kind of instruction can be sort of like having cars brought to us exactly when we need them and picked up from us when we're done. In the interest of time, I'm going to skip on a bit here because we should get to the general panel discussion. I think that just as we've seen the 3 V's or some number of V's in big data, when we think about data science education, there's sharing, scaling, and saving. I'd like to suggest these 3 S's, and that both data science and data science instruction are team sports. And so if we take a look at the value proposition for public cloud computing, we see some of these 3 S's showing up in different ways. And here at the University of Illinois, we've had a chance to start to work with these cloud computing platforms more easily in recent years. So if we think about these 3 S's in data science education, we see that there are aspects of Databricks that support each, where there are elements of sharing, of allowing members of a data science team to work together, scaling through the use of Spark and the unified data service, and then savings from the use of cloud deployments. And it's like a rental car that's just ready when you start the engine, rather than needing an extensive configuration or setup process. And that scaling can happen both vertically and horizontally. And we explore some of that scaling range in this data science course, ranging from very modest to the potential to scale quite extensively. And at the far end of where we need to recognize that scaling can happen are things like the uses of Spark at 10 cent. To make things very concrete with respect to Stat 480, these were some of the clusters that we utilized and made available to students last fall. These students used the resources to engage in some significant projects. This is one in particular that taxed a cluster in a notable fashion. Well, thanks for your patience. Those are my prepared remarks. And Colby, I think it's to you now.
Yeah, I'll avoid using slides here, and I'll make it quick. So I am an associate faculty member, as Rob said, at UNC Charlotte. So UNC Charlotte is a top-tier computing and research institution, and I want to specifically talk about how using Databricks or flexible platforms in the cloud allow us to do things that we couldn't do before. We have a fairly extensive or fairly large computing cluster here at the university that we use. Being in the genomics department, obviously there are very specific things that we use on that cluster to do our processing of in genetics. However, when we start looking at specific use cases that we need full control over, I don't have full control over our $1 million cluster, right? That's not something that I personally have. I have access to run things, but there is something that I do have access to, and that's our Azure tenant, and I can spin things up as I need them, namely Databricks, and we can get scale that we need for a limited amount of time, and then I can proceed with my next research project. And I've seen this here. Most recently, I work in infectious diseases, so I use Databricks and the Azure Machine Learning Service to do some pretty large-scale stuff with malaria research and genomics there. so it's an interesting place to do some very flexible things that you can control yourself. So kind of piggybacking off of what Donghua and Charlie were saying. And the last point is I teach cloud computing, which has been an interesting shift for students. Right, students are pros at are becoming pros at machine learning and becoming pros at like doing some stuff with data, and they're getting really comfortable with R and Python. And then we move over into Databricks and in the cloud computing course, really show them how to kind of use those skills, but then do it bigger, better, faster, stronger, all of those things. So. Anyway, I'll stop there and let us get to the panel discussion. But that's something to keep in mind that as our students start to use these platforms, it really opens up a world of opportunity.
All right. So, yeah, thank you, Colby, Donghua, and Charlie. And I think what we'll do now is just start the panel discussion, and I'll pose a question to the three of you, and then we can we'll go in alphabetical order: Charlie, Colby, Donghua, in terms of responses. So I'll let you, the three of you, do triage on there. Charlie, your microphone is amazing. I can hear the water bottle. Or yeah, no, I was like, wait, but it was nice to correlate it with the action. So thanks for that. So first question. What led you to doing teaching computing in the cloud? I know you've touched on it a little bit, but just a simple answer to that, and that'll kick it off. See, Charlie just muted his mic. Now he's got to unmute it.
So one of the things that struck me in the last 10 years or so is I've also been working as an entrepreneur in ag tech. Was that a number of firms that started slightly after me in agricultural technology started out with the cloud. And I think that they very shrewdly exploited the great scaling properties and optionality that we see with cloud technologies. And so they saw great success. I like to learn from the successes of others. And I said, this is something that matters. This is something that I should incorporate more. And it's something that I'd like students to start to think about as well, because it is a change for students. They are used to thinking of a download process and getting the data to themselves where they can start to work with it. And I think that because of data gravity and a number of other factors, we need to start to help students shift from that perspective to recognize that there are times where we simply need to move our attention and our codes to where the data already reside.
For me, there are two different factors. The first is, so outside of the university, I work for a Microsoft and Databricks partner, Blue Granite. So we do large-scale cloud implementations for both data and AI. Obviously, I work more in the AI space. And one of the things that I saw is that a lot of people, even people that are professionals in the field that I consult for, they are used to using their laptop to do everything. Data scientists were used to train their model in RStudio and, in their nice, comfortable environment. And then it seemed that that's as far as it got. And so, whether your limitation is scale or your limitation is being able to productionalize or operationalize those models, that's a place where the cloud really shines. And then the second is at UNC Charlotte, we already had a cloud computing course, but the cloud computing course was taught on slightly older technologies like Hadoop, for example. And so I kind of took that course and modernized it with things that I use on a day-to-day basis in my consulting role at Blue Granite. And so there, Microsoft helped fund that, and then basically I kind of turned that course into a course that teaches us how to architect things in the cloud, kind of from a consultative perspective, so that all students, even if you're a pro at machine learning, now you can understand machine learning at scale, for example.
Yeah, so I'm gonna piggyback on what Colby said. One of my students, she sent me an email asking me whether she needs to buy a new laptop to be part of 603 course, which we'll be teaching on a big data subject. And I told her no, because it'll be provided, but then I think, with the projects that we're giving, students are finding out that there are a lot of these big data sets that they can work with, and, they really want to explore what's in there and then get insights from that. So kind of allowing them to have that kind of experience without really being bogged down with the operational side of running Apache Spark cluster, just with a click of button, being able to, stand up 4-node, 8-node cluster with GPU capability. I think it's really powerful. And then, giving them the libraries and, like from TensorFlow to Keras to any type of AI ML libraries that are available on this cloud platform. I think that is pretty, powerful to the students, and enhancing that experience is what I'm really looking forward for.
Okay. Let's see. There was a question in the Q&A related to and I think we've got time. So when you teach Apache Spark, what data sets do you typically use, and on what platforms?
For me, I use the Microsoft Azure platform, and for my class is very project-based, and so students are allowed to use whatever data set they want, as long as it's legal or and applicable for them to use it for the course. It's kind of bring your own data, except for the first use case, which I use the AdventureWorks data set because we're spinning up data platform stuff.
So Carlin Donghua, anything to add?
Yeah, so I'm the same boat as Kobe. So far we have had our own data center in which we ran Apache Spark clusters, but as you can imagine, it's really hard to maintain. They constantly go down, and there has to be somebody who restarts them. But then, thanks to the Databricks Alliance program and help of coming from Rob, we were able to get the grant, and we're really excited to bring Databricks into our classroom next semester.
Thank you. And this is a question from Dar. I may be speaking to the converted here, but do you feel that computer science fundamentals need to be broadcast or at the very least introduced to students to maximize the return from cloud analytics? And if so, how do you feel this would be best integrated with traditional teaching subject matter? In other words, how can cloud analytics be introduced to the lay student? And I think that's it's sort of a follow-on question to our lead-off question. So I would love to hear your answers on that.
I think that as a university starts to adopt doing things in one of the clouds and even using Databricks, for example, there are plenty of cases where maybe you don't need the full power of Databricks for a classroom example, but maybe you want the collaboration and flexibility. So, for example, if a student is in, let's say, an econometrics class, that's a business student, but it's a student that could use something computational. And if I'm a teacher that teaches econometrics, which, by the way, you don't want me to teach econometrics, but if I were, I could I could administer my class from a Databricks platform. So I think it gives a little bit of flexibility for that. Things that are technical but not necessarily computer science. So I don't know that I answered the question, but I think that we're seeing that a little bit.
Yeah, in my opinion, computer science is absolutely necessary, even for a data scientist, right? Because of the fundamental concept of working with different data structures and how to optimize the performance is really crucial to understand, especially when you're working with a distributed computing system, just like Apache Spark. Understanding how the data is shuffled between different nodes. And to make that kind of difference, I think it is necessary for students to understand.
So I would also concur about the importance of a number of important fundamental topics in computing. I think that I'm somewhat sanguine about the possibilities of introducing these technologies to introducing these technologies to broader audiences. For instance, we have incorporated some digital humanities work in this data science foundation course, where we do some analytics on IMDb data sets to understand aspects of the structure of the film industry and influences there. So I think part of how we can draw a broader community into being ready to make the sort of cognitive investment necessary to be successful with some of these tools, that meeting people where they are with data sets that they already know they care about can be an effective strategy.
Great, thank you. I think we'll move on to the next topic, and well, I guess we can follow the same sequence. Maybe Charlie, Colby, Donghua. How do you work with others involved in cloud computing? And because it's something that is beyond your laptop, you have to connect to other resources. So how does that happen for you in your setting at your university?
So at the University of Illinois, I think we're very fortunate to have a very progressive group of cloud architects in the campus level IT organization, Tech Services. And so they have been excellent enablers of progress in this area. And there are arrangements that the university has that makes it so it's very easy for us to go ahead and start working. I think that it's been very nice to be able to work with the college level technical service folks, the campus level as a broader team. And when we take that approach, things seem to go very nicely and very quickly.
For us, we at UNC Charlotte, we have tenants in both AWS and Azure. Obviously, I'm more of an Azure person, but the easiest way to get that we've gotten started with that is kind of having that liaison person that helps you get set up with whether that be your subscription or resource group or whatever kind of level of resource you need. For some people, what started to happen is we've provision like a resource group and that kind of stuff for a particular purpose. But for others, let's say in bioinformatics, I create some tool that I want to host in the cloud. I can do that. And it's really just a partnership between the IT team, a trained IT team that's working on the cloud as well as you as the researcher. Or if you already know how to do it yourself, then you have free rein to do that.
Yeah, I mean, I agree with Colby that, having that partnership with IT team would be crucial. But then, just coming from, my day job of, overseeing things that are running in the cloud, we can bring the same type of, tool sets and same type of discipline into our classroom settings, right? So as a professor, I have the ownership of the subscription that I'm provisioning to our students, and then, we can just write a simple script to, govern their usage and making sure that things are getting turned down at night and things like that. So, having that in conjunction with the help from IT support will be crucial.
So what's interesting is as you were talking about the answers to this question, there was an excellent question saying we're in the process of moving from the old data warehouse model to teaching more about data science, and there were specific questions around how do you set up student accounts and then bring the accounts down on a semester by semester basis. Donghua, this one made me smile. How do you sort of limit student costs, or the costs of what you're setting up in the classroom, and how do you link student credentials to LMS institutional credentials? And deal with authorization so that professors can view student environments. So in particular, when we worked with a class at Berkeley, again, these were the issues. So if you're going to do this, you must think about these things: student credentials, monitoring, cost, and then instructor access to what the students are doing, but not student access to what other students are doing. So I'll just open that up to start with Donghua, but if Colby and Charlie, you want to add to that as well.
Yeah, I mean, like I mentioned, excellent question. Like mentioned, I mean, we can bring in same type of discipline that we are leveraging within our work setting into the classroom, right? The governance of cloud resources and making sure that things are getting turned down, and then putting quota on in terms of the number of nodes that students can spin up and down. Those can be all automated, and the thing is, I hear the stories about professors not really having that kind of governance in place when they are doing cloud computing or teaching using cloud resources and incurring costs because students forgot to turn off their cluster, for example. So bringing that kind of discipline from your industry or your work into the classroom, I think that's the way to go.
For my class, I not only use Databricks, but I also actually have students log into the Azure portal and actually spin up things. And so basically what happens is there's a group in the Azure Active Directory for the course, and I add my students every semester to that group and remove them after the end of the semester. And then I control the type of account they are. So you can give them contributor access, which allows them to spin up things, but they can't add other people. And then all of that is attached to a specific subscription that has a cap to it. So let's say if my budget for the semester is $10,000, just for example, that subscription has that hard limit. So even if a student were to do something crazy, they can't, it's not like they're going to incur a $100,000 bill. It can't happen that way. Specifically inside of Databricks, I set up individual clusters, and then the students can't do anything to edit the clusters, but they can attach to and start those clusters. And I do that by group. So let's say 5 students per cluster, per small cluster. And then also in Databricks, individual directories, student can't view another student's stuff in those directories unless they allow it.
Part of what we did in order to help manage costs and keep costs down was to pay attention to the timing of demand for compute, and have a sort of a hybrid strategy where during times when we imagined a large number of students needing compute resources, we would have a larger cluster already scheduled to spin up, and then at midnight be taken back down, and smaller clusters that would incur costs at a much lower rate, students could start and stop as they needed. So that hybrid approach let us provide a lot of compute capacity and flexibility at a more manageable cost.
Great, thank you. I think based on my experience in the University Alliance program and the answers that you got from Donghua, Colby, and Charlie, pay attention to governance, pay attention to costs, pay attention to timing, and make sure you're working with your central IT organization so that you're leveraging the resources that are there, both in terms of personnel and expertise, but also access to cloud compute resources. So let's see, I'm going to shift to our third question. What are your thoughts on the utilization of cloud computing in higher education as a way to mitigate digital divide issues exacerbated by the pandemic? So, cloud computing in higher education as a way to mitigate digital divide issues exacerbated by the pandemic. And this time we'll start with Donghua, then Charlie, then Colby. Donghua, Charlie, Colby.
Yeah, sorry, I got carried away responding to the questions. Yeah, so I mean, in terms of a digital divide, so I think, I mean, the kids are nowadays more, exposed to like Chromebooks and, being exposed to the digital learning. And I know that, Fortunately, I'm living in a neighborhood where the computer access is not an issue. But, I know that there are students out there who are not really having that kind of access, being able to get online, not having the right internet connection. So it can be pretty difficult to interface with them in real time. But then what I try to do is I try to follow up on them, via emails or any type of communication channel that are available to me, so that although they may not be, participating in the real-time online class settings, just trying not to diminish that experience that they may have, creating videos and uploading them so that they can take a look at it online, coming back with questions, either to the online class or sending them via email. So following up on them. So I think it's gonna be a little more personal level communication that's involved. So yeah, I don't know whether you answered the question, but that would be something that I recommend for the group.
I think I see immense potential for cloud computing as a playing field leveler in higher education and perhaps more broadly. So in a 400 level course where like the one I'm teaching now, there's generally fairly consistent access to one's own compute resources, but there's still going to be some differences in courses earlier in the curriculum, especially especially courses targeted at first and second year undergraduates. There is immense variability in the personal computing resources, and I've seen that directly when teaching a undergraduate biostatistics course. There's just an immense difference in what people showed up with to compute. So I think that being able to have the data and the compute resources in the same place for everyone and having them be the same magnitude can do a great deal to mitigate some of the digital divide issues. And so I think that's very promising.
I think for students that are in technical fields, whether that be computer science or engineering or statistics or whatever, there are oftentimes things that as an instructor, you want your students to be able to run locally. If you're an engineering person, maybe that's CAD, right? If you're a statistics, if you're a biostatistics professor like Charlie, right, maybe there's something from bioconductor that has to be installed. For me, I work in genomics, and actually right now I have a PhD student that is attempting to run a pretty complex piece of software that takes a lot of software dependencies to even get running. And so it's something that I can control with a nice like Docker image and spin up a compute instance in Azure and give him access to that. And we can control that sort of access and kind of so that he kind of levels the playing field a little bit, so that we're not maybe the issue is that different students come in with, one student has this really nice gaming laptop and another student has the a computational equivalent of a toaster, but with the cloud we can kind of level that playing field, and then we can also as instructors kind of control that environment a little bit better so that every student isn't running a different version of Python, for example. We've all been there.
All right, thank you. I've got a question in the Q&A that I want to go to before the next panel question. Earlier in the presentation, someone mentioned leveraging traditional retail analytic tools, recommender, sentiment analysis, etc., in an education setting. So leveraging traditional retail analytic tools in an education setting. Could you explain in deeper detail how we can integrate machine learning tools into improving a student's experience? So I'm not sure who mentioned that. I've got too many windows open, but if somebody wants to just jump in, that would be great.
I can give a quick example. So outside of Databricks, if you wanted more kind of a more canned solution for some of these NLP, natural language processing solutions, for example, the person specifically mentions sentiment analysis, right? There are other things in the AWS or Azure. In Azure, it's called Azure Cognitive Services, the text analytics API that can be leveraged on maybe comments that students are making, maybe it's evaluations of a course, that kind of thing, and it just helps to quantify how a student is behaving and does that correlate with their performance. We had a client at Blue Granite once that was looking at, it was an education client that was looking at risk factors for student attrition. So why might someone not return to school the next year? And are there any predictive indicators with that, like maybe the number of times that they reached out for help, their grades, and other factors like that. So it's not just one thing in general, but it could be part of the picture.
And also, I mean, the online learning kind of brings an opportunity for the learning experience to be gamified, right? Mike talked about, having, son who likes to play video games, but then, have not really paying attention in the classroom settings, online classroom settings. And I'm experiencing that with my kids too, right? Whenever they are in the class, they're not really paying attention. They're looking at their phone and not, really delving into the material that's presented. But, what if we were to gamify the experience of online learning and then being able to collect the data as they interact with other students and teachers from that environment, and then doing analytics on that? I mean, obviously we have to think about the privacy and things like that, but I think it opens an opportunity for us to leverage machine learning AI tools like sentimental analysis and using that data to enhance the experience even further.
So Charlie, anything to add? And you're on mute, so if not, then that's okay.
Not at this time.
All right, so I posted a summary in the Q&A response, and interestingly enough, the next question on my list was, with the move to online or distance learning, how do you see predictive analytics and AI contributing to optimizing the student online learning experience? So Colby talked about semantic analysis of the feedback that comes in from students and in particular classes, and Donghua talking about the gamification of the experience. And the marketing person on my shoulder says, hey, don't forget the Summit Quest game that's also part of this overall conference. So, part of me as a parent of both young and older kids, I'm just like the gamification of everything electronically. It has some value, but then I'm also skeptical at the same time. So your mileage may and probably should vary. Mike Maxwell, do you have anything you want to add in this particular part?
I'll just say that, my wife being a university professor, that higher education and actually K through 20 education is pretty stuck in an antiquated model with how learning is delivered and how we gauge student engagement. We're sort of operating by models that are 300 or 400 years old now, and in trying to adapt those sort of traditional classroom models to a digital medium, there's still a lot to figure out there. Having said that, I mentioned in my talk, I've had some direct visibility into, I'll mention Western Governors University, who I think is a pure play online university that, being, in delivering content that way has probably been kind of a necessity for them to address, where they've got a student population of over 100,000 students, to understand both at the individual level as well as the aggregate level, how the data can really inform them to optimize the student experience. And that's everything from looking at, combinations of content that can be that can be toxic in terms of a student's ability to graduate, how they're interacting with various digital mediums that, in a real-time basis, how a classroom is interacting with those, and really, working through seeing the data that can be drawn holistically from all those digital mediums to optimize learning. I think we've got, I think we're just at the very forefront of starting to figure that out. And I'll say on behalf of my my son's high school experience, we've got an awful long way to go to where, for at least for some kids, without a high degree of intervention from parents in the home and the learning process, it's going to be a real struggle. So innovators and new ideas, and some of our thought leaders, like at Western Governors University, I think are going to be really important in informing how we use what our digital assets can tell us about students, and again, looking at how retail has evolved to a model. Understanding customers in retail used to be very much about interfacing with them when they walked into your storefront, and that model has primarily moved to understanding how to interact with them when they're in your digital storefront. Education is very much on a path to have to go through that same revolution, and so those that are delivering education, there's going to be some very substantial innovation that's going to be needed in the coming years. In my experience, this online learning is not just a temporary a temporary fix. It is a new normal, but I think the tools and methods we have right now aren't as well attuned to the technology we have as it will be over time. So I look at data and analytics as a way to really inform educators on what works and what's effective and what isn't.
Okay. Charlie,
something that has struck me, and perhaps related notions like the opportunities for gamification have been expressed. But I mentioned at the outset of some of my remarks that I see both data science and data science education as team sports. And so something that I mentioned to my colleagues here is that we need to remember it's not just that our circumstances in which we teach have changed, but the world has changed. We are now preparing students to take part in a different kind of world. And working in teams was very important before. Working in teams, especially working in teams virtually, is likely to be even more important, especially when we think about major tech employers in California mentioning that they're going to be much more comfortable with people working from home. So are there ways to create greater interest, at least among those teaching data science, teaching cloud computing, are there ways to create greater interest by recognizing that the mediums, the media that we use in instruction in learning may in some ways resemble what we encounter in the world of work later?
And I think too, in addition to just teaching in the classroom, part of the university experience is student organizations, or maybe students participating in research and these kind of other things that's not just classroom stuff, which is hard enough on its own teaching online. But then imagine, how do we do student organizations online? How do we, I know for myself, I have interdisciplinary students from biology, bioinformatics, data science, computer science, whatever, and getting those people in the same meeting room to talk about the same thing and be engaged is difficult in and of itself. So it's how do we replace in-person stuff in all of these different areas.
So I'm I'm occasionally refreshing my screen so that I get the latest Q&A updates. So I know that some people are having trouble with their question coming up in the Q&A. So if you post it in the Q&A and it doesn't appear after a screen refresh, go ahead and post it in the sort of the chat window so that we can actually see it. So my apologies for that. One that I wanted to just call out is how do you make the students really understand the need to use Spark to process big data? That's an interesting question to me as well. It's just like, so great, this thing called Spark exists. How do you convey the need to the students for them to understand what Spark is and why it exists?
The analogy I use in my course is, sometimes you need a hammer, sometimes you need a wrecking ball, right? And so, and you don't always need a wrecking ball. That's a good key takeaway from this is that, while there are things that we can do on our local machines in a smaller context, sometimes your data sizes, whether that be the data prep that goes on for machine learning, whether that's too big to work on your machine, or maybe it's the machine learning, you want to do a more exhaustive search or much more different models or whatever it is. Sometimes there are different kind of larger use cases at hand in doing that. So that in Spark is a place to do that at a larger scale.
One of the
Rob, your mic is off.
Yes, there was a nice response from Donghua to that question as well. Look at some publicly available healthcare data sets, and they soon realize that they'll get quite large and they can't ingest them on their laptop, let alone do the calculations. So, all right, go ahead, Charlie. I'm sorry.
So I think that inviting consideration of sort of medium large or large data sets where we have to attend to data gravity is indeed a great way. And I think it's something that we're going to do increasingly. Another thing that I'm introducing in the second offering of this Spark-oriented Data Science Foundations course is to recognize that I primarily have statisticians as opposed to computer scientists or computer engineers as students. And they have not necessarily had a need to encounter questions of how long computing takes in the past. In some ways, they've even been shielded from that by what is thought of as an appropriate problem. So some of our first exercises in this course will be to invite them to turn their attention as statisticians to measures of computing performance in different tasks, and helping them get a sense for the fact that indeed we have to consider computational effort and cost in some circumstances, in that we can use familiar tools of statistics to do comparisons so that they get a chance to participate in that exploration of the need to think about these things at all.
Yeah, I mean, I call Apache Spark a Swiss Army knife of data. So using Spark, you can almost do anything from data ingestion with different connectors that it brings in its ecosystem to data wrangling. I mean, Spark Databricks team is already working on Koalas, which is API compatible to Pandas data frame. So they are reducing that friction to have going from just single node system on the laptop to multi-node clusters. So, just exposing them to Apache Spark where, enable their, or, increase their capacity to be able to ingest a large data set and then, work with different data sets at the same time in different formats and, being able to just, be creative with their solution. So for that matter, I mean, I think Apache Spark is a great platform for the students.
Great, thank you, Charlie, Donghua. So Jishnu, in where Kristen has sent me your questions via Slack so that I can answer them. They're not showing up in my chat window. A couple of questions related to, as an instructor, how do you gain access to data that doesn't fit on your laptop? And then how can you help the students access that data? And then those are two questions I'll just throw out there. So where do you get the data, and then how do you help the students get access to it?
One of the places that you can often find kind of larger scale data is in kind of challenges or competitions. So right now, at Blue Granite, working on a demo that uses some COVID-19 data that's out by the Precision FDA team. So it's about predicting COVID-19 risks, and we're using Databricks, literally running something right now. And usually these kind of challenge sites have this kind of large data set that they want you to do stuff with, and it's often fairly open-ended. So they're not saying, here's your perfectly shaped, clean, trained data set. In this case, it's 16 tables of stuff, and you have to shape it yourself and cleanse it. So just to reiterate, I would say challenge sites is a good place for that.
And Colby, if you have a moment, if you've got them phones handy, post them in the chat window, or maybe as a question and an answer.
Yep.
Thank you.
And if I was keeping up with some of the posts, I think that Jishnu also asked about possibilities of the Alliance sort of assisting in making compelling data science data resources available. And that's something that I've tried to talk about in other contexts, for instance, collaborating as a campus or collaborating among the Big Ten academic alliance institutions to recognize that some number of classic data science data sets used in instruction could be gainfully situated once and to be ready for use by many later with less effort.
Yes, I encourage students to look after some of the publicly available data sets, including those data sets that are published by City of Baltimore. It's a really interesting data set on the crimes, housing, healthcare, and then even New York City, they have a huge data set that they publish. So, and a good thing about these data sets are sometimes they are not clean. So it brings out an opportunity for them to go through the exercise of cleaning the data. So you get the benefit of having a huge data set along with being able to teach them on how to merge and clean the data sets together.
All right, thank you. The system has informed me that we're in the 5-minute warning, so there will be no referee stoppages of play. We will just continue to go. One quick question and then a more involved question. So one sentence answer from each panelist. Do you imagine that you are preparing your students for work in positions which are primarily on-site, remote, or a mix? Go Donghua, we'll start with you and work backwards.
Yeah, mixed. Definitely mixed. So, we are providing opportunity for working remotely and also in-house. So,
Charlie.
Mixed with trend towards remote.
Colby.
Yeah, I would say mixed, but I think that it may transition over time as we put COVID-19 behind us.
All right, so leave your mic on, Colby, and now we'll go work backwards with the last question on my list, and that is, what outcomes have you seen that energize you and keep you moving forward? And for me today, it's been this panel and the audience. It's been fantastic. So Colby.
Yeah, from my perspective, I think the biggest thing is research ability in the cloud. Because I work in genomics, I've been using the Databricks genomics runtime and Glow. I have a recent blog post about that you should go check out. It's really interesting to see how you take something that is very important and traditionally done in this kind of bandaged way and using a bunch of open source software, and then you take a company like Databricks that can and partnerships with Regeneron and others, and they've really turned it into a truly usable product that we can use for really interesting biomedical use cases in the cloud. So I think that to answer your question, I think the biggest thing for me is the ability to do research at scale, and to continue on and collaborate in the cloud.
So something that I found to be very energizing, I've taken a bit of a look at aspects of COVID-19 also, and in particular I was struck with the profound importance of population density. And so I was delighted to be able to use Databricks to process Season's gridded population of the world data set and see things that were surprising and compelling with respect to the profound differences in population density across the surface of the Earth. And this is a time when those differences matter with respect to how we both work to address the problem and how we understand others' reactions of different sorts, both to COVID-19 itself and steps taken to mitigate risks from COVID-19.
Yeah, I mean, just being able to provide the experience to students, first-hand experience of working with distributed computing in the cloud, and then seeing them making impact at their work right out of college from day one. That's what excites me.
Okay, we've got 30 seconds left. Actually, it says 1 minute, but they're going to cut us off a little early. Mike, anybody have anything else to add? Just know that this content will be hosted in perpetuity, including the Q&A. So I posted some links in the chat window, but thanks everybody. Any closing comments until they cut us off? Take it away.
I just want to give everybody a big thank you, both the panelists and Rob and all of our audience. So thanks, everybody, and best of success to you all with Databricks and education.
Thanks for having us.
And there is the Education Forum Lounge. So there will be, some of us will be in that lounge after this event. All right. Donghua, Charlie, Colby, thank you very much. We will shut the session down. Audience, you've been fantastic. Take care.